C# 9 is out, and with it comes a new and somewhat confusing feature, records. In this video, we're going to look at what records are, how to use them effectively, and then we'll talk about when they would be useful, and just as importantly, when you should not use them. Now, if this is your first video you've watched of mine, my name is Tim Corey, and it's my goal to make learning C# easier. I provide videos twice a week here on YouTube to help you grow as a developer. I also have a full set of training courses on IamTimCorey.com. I would encourage you to check out all the resources I have to offer. In this video, as with most of my videos, I'm going to create some source code. If you'd like a copy of my source code, use the link in the description. Also in the description is a link to sign up for my mailing list. Next week, I'll be rolling out my annual Black Friday sale. Make sure you're on the mailing list so you get all the details. Now, let's get started looking at records. I'm in Visual Studio 2019. This is 16.8.1, which is the latest general release version. It's not the pre-release or anything like that. It's the latest general release. Let's create a new project. We're going to create a simple class or console application. So console.NET Core, and we'll call this our record demo and record demo app. And once it's created, I'm not going to create a top level class here. I could, but what I want to do is, because this is a demo and I want to show you more than one thing on the screen at a time, I'm going to cheat a little bit. And by that, I mean, I'm going to put my record creation right down here, starting on line 13, instead of putting them in their own classes. I would definitely recommend you create their own class files, that is, their own class files for the records. But because I want to show you on the screen both at the same time, this just makes it a lot cleaner. So let's start off with a very basic, straightforward, pretty common declaration of a record. We can then see and then talk about and compare with what that might look like if it's a class. So public record. And it's going to yell at you and say, no, I don't have this. And if you mouse over, it says that record does not exist in the current context. That's because we're in, by default, .NET Core 3.1. If you right click on your project and go to properties, you'll see target framework of .NET Core 3.1. The cool thing is you just select .NET 5.0 and save. Oops, not open, save. And you're good to go. Now, what that does behind the scenes, just so you know, is in the CS proj file, if you either right click on it, if you click on it singly, it'll go here, or you can right click and say edit project file. But either way, this is the project file, very, very simple, which is awesome. And the target framework right here is .NET 5.0. That's the big change that we had before. It said before, I believe, .NET Core 3.1, and now it says .NET 5.0. So that was a big change in our project file. That's it. So with that, we can now use record. Now I'm going to name these records with numbers. We're not going to get into trying to simulate a real world thing here. I want to be very clear as to what each is, and it's always a demo. So we're going to call this record 1. It makes me cringe doing it, but it makes sense when we look at how we're going to try and keep track of everything. So record 1. String first name, string last name, semicolon. That is a declaration of a record. You've got the record declaration instead of class. We have our name like normal. And here what I've done is it looks like a constructor, right? Where we've passed in parens or parentheses. I say parens for short, just so you know. We pass in first name and last name. And notice I'm not using camel case here, meaning a lowercase f and a lowercase l for first and last name. I'm using Pascal case where each word gets its capital letter. And the reason for that is because what this does is it actually behind the scenes does a whole lot of work for us in the record declaration. And this is where really the power of records comes into play. So let's talk about what is happening behind the scenes here. Let's first start with a bit of the confusion. You've probably heard it say that records are like value types. And if you don't know what that means, there's value types and reference types. And normally classes are reference types, always the reference types. And what that means is when you copy a class from one or pass it around, you're not passing the actual class data around. You're passing a reference to that location. It's kind of like when you build a house, you pass the address around of the house, not the physical house, copying it. That's what a reference type is. A value type, you're actually making a physical copy of that data and passing that around. Well, records act like value types, but they are not value types. They are reference types. In fact, and this is a very important thing to understand, that a record is just a fancy class. That's it. It's a class with extra stuff. That's all it is. So don't get too caught up in value types versus reference types and how, value types are better because they're faster. No, it's a reference type. That's what this is. It's just that records have a whole lot of things going on behind the scenes that are happening for you. It's kind of like some pre-built code to make your life easier. And we're going to see how to use all that pre-built code today. Let's start with the very basics by creating a class that is similar, not the same, but similar. Public class, we'll call this class 1. Again, in order to indicate that it's the same as record 1. And in here we'd say prop string first name, prop string last name. At a very high level, this declaration right here is similar to this declaration right here, where we have two different properties that have been created. This is going to be a property, and so is this. Now, to make it closer to a record, this class should actually have init instead of set. Now, if you watched my previous video, you know that init means that you can only set this value in a constructor or when you create the class using the curly brace syntax. So that brings us to the next feature of a record, and that is it's immutable. I think that's how you spell it. We're going to run with that one. Immutable, which just means that it cannot be changed. The values cannot be changed. All right. So what that means is that once you set the values in a record, they can't be changed by default, by design. So think of a record as a read-only class. That's pretty much what it is. It's read-only. Now, there are ways of getting around this. You can make it mutable, which means you can mutate it or change it, but that breaks the design of the record and really hurts some of the benefits that the record provides you. If you need your values to change inside the class, then you really need a class. Inside the record, then you really need a class. So a class, we can change the first name later if we want to. Normally, this would be a set here. That's a standard class. Well, you can change those values. In a record, we basically lock it down to be read-only. That's the immutability of records. Now, we'll see in a little bit how to make copies so that when you want to change the state, you actually create a new version of that class or that record. So we'll see how to do that in a little bit. But that's one of the other things about records is they're immutable. Now, I said that this representation of a class is similar to this record, but it's definitely not the same. There's a lot more that goes on behind the scenes in a record. So we're going to keep adding to this class and kind of see what else we can see out of it. Well, one of the things is that this is actually the constructor signature. So let's create a constructor for class 1 that's similar. CTOR, and we'll say that you need to pass in string first name, comma, string last name. Notice I'm using camel case here because that's what we do with parameters, which these aren't quite parameters. They're more like a definition. Therefore, they get the Pascal case. So here's a tip I've learned recently. I don't know how soon this was put into Visual Studio, if it's recently or not, but control dot here, I can say initialize property first name. Click on that. And now it says first name equals first name. Really awesome feature here. So control dot, that's a little bit of boilerplate code that I've had to type over and over again for years. It's nice to be able to control dot and just do it automatically. So now we have closer to what the record provides in just this one line in these, 10 lines of code? See, we've got the two properties. We've got the constructor that assigns the values. We've got all that in record. But also record has a lot more, like a deconstructor and an override for equals and not equals and an equality check and so on. We're going to see all that right now. Let's start by coming up to our static void main. And we're going to get rid of our initial line. I'm going to create 3 records and 3 classes. So they're all going to be record 1 is the class or the record name. And we're going to call it R1A equals new. And we'll say Tim, Corey. And then we'll have, I'm going to copy this line right here. I'm going to say, paste it 2 more times. We'll call it R1B and R1C. These are horrible variable names in normal cases, but in our case, I think they're a little clearer. So R1 refers to, this is a record 1, meaning this is a record object, and A, B, and C are the 3 different ones we've created. This last one here, we're going to change to be Sue and Storm. I create 3 classes that are exactly the same, except I'll say, well, you'll see. Class 1, C1A equals new Tim, Corey, like so. Let's copy this, paste it 2 more times, and we'll say B and C. This last one is Sue, Storm. All right, so just to recap real quick, I have 3 record objects that are all record 1 type. And I'm calling them A, B, and C. And then I've got 3 class objects, which the class and the record are going to act similarly. So we have our first name and last name. I even made them inits. So it's similar, but not quite the same. And I've got class A, B, and C as well. The first 2, so A and B for both of these, the values are the same. So Tim and Corey for both A and B record for both record and class. And the last one for each is Sue Storm instead. So now we have our test cases. I want to show you a quick setup. So we're going to say console write line, record type, and then we'll do some spaces down here. We'll say console write line that's empty, console write line that has a whole bunch of stars in it to differentiate, and then another blank console write line, and we'll say console write line, and this will be class type. So what we're going to do is some comparisons of how the record behaves versus how the class behaves in our console write lines. The first one is really simple. Console write line, $, we're going to say ToString, and then in double quotes, we'll say R1A. That's it, just R1A. So we'll do the same thing for our class. So instead of R1A, we'll say C1A. So we're going to print out just the actual object itself. Now, if you're familiar with classes, you'll know that when a class gets printed, it's going to say our namespace, which is record demo dot class 1. We're going to see what it does for our record. So as you can see, there's our class. It says ToString is record demo dot class 1. Our ToString for our record is record 1, and then curly brace, first name equals Tim, last name equals Corey, close curly brace. That's a lot more readable. And that's one of the benefits of a record is it actually overrides the ToString method. And it gives you this nice, neat value of everything in the object. Personally, I wish that classes would do this, but they don't. So this is the first value or the first bonus of using a record type is that nice ToString. If you've ever used a dropdown and you put objects into it and forgot to assign the display value, and it just decided to do a ToString on each of your objects, and they repeat over and over and over again, record demo dot class 1, and you go, what's the matter? Well, that's why. You've done a ToString on your object. At least with the dropdown, it would now say, oh yeah, that's my objects. It's just not printing out properly, but at least I can see the values. So little thing there, there's definitely some uses for that, whether it be if you want to, very quickly log something, you don't want to go through the hassle of grabbing every property. Just doing a ToString on the object will get you that without having to do right now we do a JSON serialize. JSON serialize and then capture that string. But so it's just a nice little feature there to override the ToString. So that's the first thing to look at. Here's where we get into some more interesting territory, though. Console write line, and let's say, $, which is our string interpolation. It will say, are the two objects equal? All right. And the object we're going to compare, we're going to say equals R1A, R1B. And close curly braces. So we're going to compare this object right here and this object right there. We're going to say, are those two equal? Well, they are two different created objects. I can tell you what a class will do. Let's copy this and paste it down here and change it to class and class. So C1A and C1B, which again, they have the same values too. A class equality looks at the place in memory it is. Remember that when you create a class, it's kind of like building a house off of blueprints. You build the house and then you record the physical address of that house, the location where the house lives. And then when someone says, hey, where is that class? You go, it's 123 Sesame Street. There's the address. And you pass that address around, but they're all pointing to the same house. But when you build another house off of that same blueprint, it has a different address. So equality is going to say no. Let's look at records. So there's our equality equals false for our class. But up here, it says true. Those two objects are the same. Well, how are they the same? Because they have different, they were created differently. They were created 2 different times in 2 different objects. They weren't just copied. Well, the reason why is because this is where that concept of records act more like value types comes in. Because if you say if variable A has 1 in it and variable B has 1 in it, and you say, are A and B equal? It's going to say yes, because the values are the same. Well, this is one of the ways that records acts like a value type, because it compares the values inside the object to identify if the 2 objects are equal. Okay, so that's another thing here, and that is that behind the scenes, and this is something that our class down here is not doing. I'm not going to write the code to do it, but essentially what happens is there's another method in our record that's not seen, that what it does is it overrides the equality and says, we're going to compare every property to each other in the same object. And if, in our case, first name from object A equals first name from object B, and last name from object A equals last name from object B, then the two objects are equal. That's what it's doing. We don't have that override of equality in our class. It's just comparing the address of our class instance. Now, just to be clear here, let's copy this one more time, and we're going to say object reference equals. Now, what reference does is it looks at the address on disk for anything, not just the value. It's going to look at the actual location where this is stored and say, is the location where this is stored the same as the location where this is stored? And let's go ahead and copy this and come down here, and we're going to say C1A and C1B. So now we're do the reference equals for both records and classes. And notice that no, they're not in the same location. They are the same object as far as value goes, but not as far as location goes. Whereas down here, both are false because they're neither in the same location, nor are they the same when you say equals, because again, it's still looking at the location. So they are equal in value, not equal in where the data is stored. Now this method right here is doing an I-equality check. There is another way to check equality, and that is if let's copy this line because it's easier than trying to retype this over and over again. I'm going to say double equals. So instead of equals like this, we're going to take this code out and say, does R1A double equal R1B, like you would in an if statement. So this is a different equality check than this is, just so you know. They do slightly different things. But Microsoft, the developers at Microsoft have thought this through and say, you know what? We're going to do I-equality all the way down. And so they've overridden both this and the not equals. So we're going to see that this still works. Let's make sure we change this to class 1A and class 1B. If we run this again, you'll see that double equals is true here and false here. Because again, it's doing that I-equality check, and it's going to compare the values here, not the reference location. So even double equals works. You can also flip the script if you want to. Let's do that just to show it. Not equal. And in this case, we're going to do R1C. Because remember, C is Sue Storm. So again, we'll do C1, C1A and C1C. And we're doing a not equal here. And again, this is not equal. And yes, this is not equal as well, because this checks for the location on disk. Of course, they're not the same. This checks for the value not matching. So they've overridden this, and this in our record type. But that's not all. Let's do another console write line here. And we're going to do our string interpolation. And we're going to say hash code of object A. And we'll say R1A dot get hash code. There we go. And we'll do the same thing for B and C. So object B, got ahead of myself there, and object C, and we'll change this to B and this to be C. Then we'll come down here and we'll paste it again, but this time, whoops, got an extra line there. This will have class 1 A, and we'll do the same thing for, actually let's copy these because it's easier to change it one time. Class 1B and class 1C. So there we go. Now we're going to check the hash code. Now, if you're not familiar with the hash code, what it is it takes all the stuff in the object and it creates this unique code based upon what's in the object. And that code can be used to identify if the object has changed. Because whenever you change anything inside the object, the hash will change. But that does mean that normally you would look at it based upon its location on disk as well, but they've overridden that for records. So now 2 hashes, we notice here, notice down here for all 3 objects, the hashes are different, even though these first 2 objects have the same values. That's because it bases it also on the location in memory when you're talking about a class. But in our records, these 2 right here are the exact same. And the reason why is because they've overridden that hash code to be about just the value inside the object so that you can say that yes, object A is the same as object B. That can be really useful when you talk about the idea of what if you want to have a list that has no duplicates in it? Well, just do a link query based upon the hash code and say, give me only the unique ones. That would do that. It would eliminate all the duplicates. So let's close that out. So we've seen here in this testing section that records override the ToString. They override the inequality check, which also means they override the double equal and the not equal. They override the hash code, and they allow us to create essentially all of this code plus all those overrides with just this one line of code. But it gets even better than that, because let's go down below our last console write line. We're gonna do some work down here that we don't need to write out necessarily, but we probably will just to demo what it does. So let's put a blank line in between, just so we know that there's other stuff coming that's not in this head-to-head comparison. I'm gonna leave this always here for you so you can kind of see and look over the source code. Remember, you can download it from the description. But one of the other benefits of this type of declaration of a record is the fact that we can say var, let's do fn ln. This is a tuple. So I've declared this is a var instead of trying to give it a type name. I said var. I'm going to declare this anonymous tuple. I don't need to give it a name. I can just give the name of the object inside. So fn for first name, ln for last name equals r1a. What did I just do? Well, if we do a console write line, we can say string interpolation, so our $, the value of fn is fn, and the value of ln is ln, like so. So you can see exactly what I just did. Let's run this. And the value of fn is Tim, and the value of ln is Corey. How did it get those values? Well, this uses what's called a destructor. And so what it does is, or deconstructor, I guess is probably a better word. What it did is it deconstructed this back into its constituent parts because we declared it with these 2 values. Therefore, we can deconstruct it based upon the same pattern. So the first value coming in will be first name, the second value coming in will be last name, because that's the order we declared them in when we created the record. Therefore, they go right back out the same way. So I can use a tuple as the capture value and just say equals and my object and deconstruct it back into its parts. If I want to do something similar in my class, I won't do all the overrides and all the other stuff that they do, but let's just talk about that deconstruct method. It looks similar to this. Public void deconstruct out string, first name, out string last name, because that's the variable names will come out as, and say first name equals this dot first name and last name equals this dot last name. So what that would do is it create these out variables, which would turn into a tuple, and this is actually what the IL code will look like, the intermediate language code that C# gets compiled into. It'll create this deconstruct method. It will have an out for every property in the order of the constructor, and then it will send the property values out those out variables. So that's essentially what it's doing if we had to write it ourselves. But we don't have to write it ourselves. We have to write that one line of code. And again, now we have all of this code plus those overrides we talked about up here. But we're not done yet, because we can also create copies of these. Remember, these are read-only. So if you wanted to maybe change the state of the object, you really can't. They're kind of stateless. But what you can do is create a new object with most of the old values, but maybe one changed value. And with a class, that's kind of hard to do. You have to list all the properties, copy them over one by one, and then change that one value. But not with records. With records, what you'd say is record 1, and let's say R1D, you don't have a D yet, equals R1A with first name equals John. Well, now we have taken R1A, made a copy of it, and just changed the first name value to be John. Now I don't have a lot of properties in there, so you only have the last name being Corey is the only difference. But let's console write line and just say John's record. And we'll use that nice syntax of ToString, R1D. That's it. Notice I'm not saying .ToString. This is implicitly what it's doing. But I don't have to specify that, because by default, if I don't specify it and I'm putting it in a string like this, it's going to print out that string. So that's what it's doing. But if I run this, we'll see that John's record is first name of John, last name of Corey. It made a copy of my record, and it just changed the value of John. That's another thing that records allow us, is to say, hey, take another record and use most of it, but then this with here, anything you put in this syntax, any property you change, will change the original value, that copy. So we're going to copy first name over, but nope, we're not, because we're going to override that first name copy. But we're going to copy last name over because there's no override for last name. So that's what it's doing. It's making a photocopy of this and putting it here. And that's another reason why they're like value types. Records are like value types, because we make copies of them when we want to change their values. So those are the big benefits or things that a record provides you over a class. Remember, again, records are classes. They just have extra stuff around them. And so that brings up one of the questions that I get asked is, well, what's the difference between a struct and a record? It seems like they're the same thing. Nope, they are not. Because remember, a struct is a value type. It is not a class. It cannot be instantiated. It cannot be inherited from or inherit. We can inherit with records, and we'll talk about that in just a minute. And it's kind of apples and oranges here. A record is much, much closer to a class than it is a struct. And we're going to get into when we would use records nearer the end. But first, I want to go over some questions I'm sure you have around creating records. Because we only create records one way, and that is this way right here. And so you may say, well, let's minimize class one. You may say, yeah, but Tim, there's just so much that I need to know here. Like, what about methods? Can a record have methods? Absolutely. Well, what if I want to modify how this property gets created? Can I do that? Absolutely. What if I don't want to use this syntax to create a record? What if I want to create like a class? Can I do that? Absolutely. What if I want to inherit from one record to another? Can I do that? Absolutely. What if I want to inherit from a class to a record or a record to a class? Can I do that? No. Records have to inherit from records. Classes have to inherit from classes. So let's see some of those scenarios I talked about to kind of clear up some confusion. Public record, record 2. And we'll start off by initializing the same way we did record 1. So first name, last name, cool. There is our new way of, our new record, record 2. Again, it's new record type. But maybe I say, you know what? I want to make a modification to how first name is created as a property. No problem. What you do is you take off the semicolon, you open some curly braces. So you still have this declaration up here, but then you have curly braces. And I can say, you know what? I want first name to be changed the type instead of being public, because since this is public, then this is public as well. But maybe I don't want that. Maybe I want it to be internal. No problem. Internal string first name. Whoops. First name. Get init. Remember, it's a init, not set. Equals first name. Like so. So what you're doing is you're declaring this property explicitly, and you're assigning the value that's being passed in. Now, there's an interesting little quirk here about this. I'm not sure if it's intended this way or if this is a little bit of a bug. I think it's intended this way, but I'm not positive. And that is, let's come down here after John's record. We're going to do let's do a console write line, just an empty one to clean these up. And we're going to say record 2 R2A equals new. And we're going to say, again, Tim Corey. Now let's do a console write line and say our string interpolation. Record or R2A value. R2A. Like so. So I'm going to just create that record and print out its value. Let's run this. And we're going to say R2A value is record 2 last name equals Corey. Where's the first name? It's not there. But yet it's actually in the object. In fact, if we were to do this and say console write line again, and let's say R2A FN for first name, R2A dot first name, and space LN colon R2A dot last name. Just to print out manually those properties. If we run this again, you'll notice that the first name is Tim and the last name is Corey, and yet it does not show up in the signature. And that's because we have overridden that property. Now, there may be some type of code I have to write in addition to this in order to get this back into that ToString method. I'm not positive. Maybe it's a decorator or something else I have to add. I have not found that yet, though. So just note that that does make a little bit of a quirky change to your code. Now, let's talk about what if maybe you don't want to do that, but maybe you want to add another property. Cool, no problem. Prop, string, full name. And this full name property, instead of having a get and a set, what we're going to do is we're going to say get arrow, and we'll say string interpolation, first name, space, last name, like so, with a semicolon at the end. Oops. Semicolon at the end. Not that end. Wow. There we go. So what this is, it's a read-only property, which, remember, records are designed to be immutable, unchanging. Therefore, this is perfectly fine because it's not going to change anything, but what it's doing is it's providing you that full name, which is first name space last name. Let's run this again, not changing anything else. And if you notice now, the full name shows up in the signature. So you have last name and full name. I'm wondering if, let's make a quick change. Even though we made this public, even though this is basically overriding the original value with the same exact value, let's just see if this will in fact give us back Tim, or actually John in this case. Yep, or Tim. Nope. First name is Tim, last name is Corey. It's out of order. That doesn't matter. And full name is Tim Corey. So it does give us back our value if we make it public. So that internal is throwing it off. I'm not quite sure why, because internal still should work in the entire assembly. So it must rely on a public, since it's public as the type of record, it must not want to potentially leak information outside the class that it should not know, or outside the assembly that it should not know about. So maybe that's why it was doing that. Maybe that was just my quirk there. But it's now put this value in the signature. So it's going to compare those, which of course is get only. It's based upon the values inside the class. Not a problem. But that's how you would add your own property if you want. But what if you want to go even further and say, well, I want a method? Not a problem. You can say public string say hello. Return our string interpolation and say hello first name, like so. Really complex method we have there, but we can console write line at the end. And actually, let's be honest, console write line. And R2A dot say hello. Call that method. Let's run this. And hello, Tim. So it has read that and executed that method. Not a problem. So even though by default, this syntax is so simple, if you need to, you can make changes to it. Now let's just one more thing I want to touch on, because it may come up as a question as well. We've said that this is basically the same thing as what you would have gotten if you took this out. So let's make a tweak to this. Let's say prop full for a full property, string underscore first name, call it first name like so. This is a full property, and let's set this, instead of a set, we need to say a init. There we go. And for our get, instead of returning the full first name, let's do this where we say first name dot substring, and we'll start position 0, and we'll go 1 in length, meaning only give us one character. So there's our our substring of 1, meaning we're only going to return back T for Tim. And we have to assign this value. So in the private string first name, we're going to initialize it to first name, which I know this is confusing. But you have first name here, we have first name here, we have first name here. What's all this about? Well, this initializer is going to read this as the parameter string name first name. We have to name these two things the same thing in order to make sense. But unfortunately, it does mean that it looks like we're stepping on toes, but we're not. C# is smart enough to know, okay, that object actually goes, that's actually the parameter, and that's going to be put into our private backing field. This is the actual property name. Therefore, that's what's going to be used to, again, get and only init, not set. So with that, changing nothing else, let's run this again. And you'll notice that the last name is Corey, first name is T. Full name is T Corey, because we're referencing that property that says, hey, when you get something, only get back just the first letter. And again, the first name is T and hello T. So this could be useful if you are storing, let's say, a social security number or a credit card number. Please be very careful how you do those things. But if you were, or something similar, where it's sensitive information, but you want to say that, yes, I've got it, but I'm not going to show you normally. Well, you could say, for a social security number, there is, 3 numbers and a dash, and then 2 numbers and a dash, and then 4 numbers. Well, typically we show the last 4 numbers, but that's it. Well, you could return, instead of just those last 4 numbers, you could say star, 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 dash, star, star, dash, and just the last 4 numbers. There's a lot of things you could do like that to mask most of it, but show that, yeah, I've got it, but I'm not going to show you. And then you could have a special method that got the full value that only be used for high security stuff where you've passed some clearances. So lots of stuff you could do there with full properties, and this still works with records. Just make sure you do init, not set here. And man, was that ever a lot of stuff to cover all at once. We have covered, and let's go back and just kind of touch over again, records are by default immutable, meaning they do not change. They're read-only once they're set. We can declare them very, very easily by just doing this type of syntax. But if we wanted to override it with our own values, we could still use this syntax, but then put more values in here. Now, if we don't use this syntax, we can still create like a regular class like we did in this class, and then create a constructor like so that would take the values in if we wanted to, or we could just use the curly brace syntax. But if we do that and don't use this syntax right here, then we don't get the nice destructor, which is this type of thing right here. So that kind of limits what you get out of your record if you don't use the full syntax. Now, we've talked about how it overrides the ToString, it overrides the iEquality. It doesn't change reference equality, meaning that they will be different places on disk, and yet they're the same value comparison, just not the same reference comparison. It does override the equals and the not equals. It does change how hash code works in order to make sure that if the two values are the same, then the hash codes are the same. The last thing I want to talk about before and we can use the with statement. Wow, there's a lot more stuff. Deconstructor and the with statement we can use as well. The with statement allows us to copy from one object to another that's actually behind the scenes hiding a constructor that takes in itself, like its own type, and then it does the copy behind the scenes, but then allows us to override one or more of the values if we want to. And after all of that, we still have one more thing to cover, and that is inheritance. So right now we have record 1. But what if you wanted to create a user record? Okay, so record 1, pretend this is a person. This is a person with just first name and last name. But now we have an employee database where public record user 1, which is going to have an int ID and then these values as well. It would seem like you'd want to inherit from record 1, which we can do. Oops, don't need the strings in front. That's how you'd inherit from another record. So user 1 inherits from record 1, meaning we now have this constructor, which has the 3 values, and we're saying, okay, 2 of those values need to get passed into your base class to initialize it, and now we'll just have one additional property in user 1, and that's the ID. Again, you can still use this curly brace syntax if you wanted to, where you say, let's go ahead and do some extra stuff inside of user 1 and apply all this same type of logic inside of or modifying this record. But just this syntax right here will allow user 1 to inherit from record 1. The keys to remember here are, first of all, a record cannot inherit from a class. Can't. But a record can inherit from another record. You do need to pass the values in for the constructor in the object you're inheriting from. So in this case, I'm asking for 3 parameters. You may say, well, Tim, isn't that duplication? Shouldn't you just ask for ID and then pass in the values of first and last name to record 1? Well, where are you getting those values from? You have to get them from somewhere. Well, you ask for all the values in this object. The only thing to be added or created is the ID property because we're inheriting from record 1, which has the first and last name, and we're passing those values in from our constructor on user 1. So these 2 values go over here to record 1, and then this value gets put into the user 1 class. So that's the, I hate to say basics, because there's much more than the basics, but that's the introduction to records and all the things they can do and how they do them. But let's talk about why. So far, we've seen this cool new thing, and yeah, it's fun, but why would you ever need records? And that's always a good question to ask whenever you see new shiny stuff is, yes, but why do we have this? Because oftentimes, especially in a mature language like C#, we are not getting brand new things that are so amazing and we need it for everything we do. Because mostly those things are already covered. The one exception, I think, in C#9 is the not. That thing, we needed that since C#1. But just now in C#9, it came out where we can say is not null. I've been waiting for that for a long time. But records aren't one of those things where I've been saying, oh man, I've been waiting for this. But they are useful. So let's do this. Let's go back to the very top, and I'm going to put in here some comments. My thoughts on records. Let's start with the benefits of records. I can type. And the first benefit that I see is they're extremely simple to set up. I mean, if you go look, let's minimize this. That right there declares a record. Compare that to all of this stuff. That is super simple. I love it. So it's simple to set up. Thread safe. Since it's immutable, a record is by definition thread safe. Now, if you make it mutable, it is no longer necessarily thread safe. And what I mean by thread safe is if you have two different threads operating in parallel and they're both working on the same object at the same time, if they both change the value of last name at the same time, that can cause a conflict. That's where you have problems because you're both trying to write at the same time and it basically blows up. Since we can't change the value of any object or any property inside of a record by default, I keep saying by default because yes, you can force it to do the wrong thing. But by default, since you can't change the values, then there's no problems because you can read from the object by more than one thing at the same time. It's only the writes that cause problems with threads. So therefore, they're perfectly thread safe. And another benefit here is they are easy, let's say easy/safe to share. Meaning I can pass these things around all day long and not have to worry. Let's take a scenario for a minute. Let's look at our class 1 here. If I were to pass this instance of class 1 around to another method and say, hey, I want you to print out the values in this. And that does it, and then it comes back. Well, it didn't actually copy this class. What it did is it passed the address of that class and says this class instance lives at 123 Sesame Street. Well, because it passed that address around, that calling method could change the first name to Timothy. And then that would affect this method. That would be a problem. I can't stop that. Well, with a record, I don't have that problem. I can pass it around all day long. It's a reference, but just because you can see it doesn't mean you can change it because it's immutable. Therefore, I can pass it around to other methods and not have to worry about the value changing, the information inside of it changing unexpectedly. It just can't. So let's talk about now, those are the benefits of records, but let's talk about the when to use. When to use records. And this is a tough one because there's not this overwhelming pool of things we can pull from. There's not like this list of 100 reasons why you would use a record. With a class instance, there's hundreds of reasons why you'd use a class instance. But with records, one of the areas is if we are capturing external data, that doesn't change. For example, if we read from that weather service, in Blazor, we have that demo code that's in there in the template where it says weather service, and it's technically just pulling from random data. But if you pull from a real weather service where it said, okay, the high today is X and the low is X and it's going to be cloudy and so on, you don't need to change that data, do you? Well, no, that's just informational data that you gathered. Another one is a Swappy. By the way, it's I've used Swappy before. It's now swappy.dev. It used to be .co and now it's .dev. But Swappy is a Star Wars API. It's a really commonly used sample API to display data. And so you can look up a person and say, hey, which movies do they appear in, and so on. But if you looked up, let's say Han Solo, and it comes back with here's the movies that Han Solo was in, and here's the other characters he's interacted with, and here's the the ship he flies in his co-pilot and all the rest, you would not expect to change that data. Therefore, a record is a great option for that, because not only does a record mean it's read-only, but again, it's really easy to declare, and it gives you all those benefits like comparing value types and making sure that you can have that nice ToString print and the hash code is the same. And all this other stuff you can do with it, the Deconstructor, all that comes with that record, and it allows you to have that nice experience when working with the data from that external API or this external API or something else like that. And speaking of APIs, another time when these are valuable is when you have your own API calls. Because a lot of times what happens is you get data from a database and then send it out the API. You don't modify it in between, you just get it and send it. And when data comes in, you might not modify it either. You just get in and then you send it into the database. Well, probably most of those could be records. You have to look at, is there any time where we mutate or change the data? And is that done in the API itself? Not the user doing it, is the API itself doing it? Another case would be whenever you are processing data, meaning you get data from your database and you're doing something with it or based upon it, but you're not changing the data. And this could be a really interesting one because it might be one where you merge the two concepts, classes and records, together. There is a potential case where you would create a class that contains a record. Let's think about this for a minute. Let's say you have a database of 10,000 people. And those people, you want to check to see if they have had any incidents online that you find troubling. So what you're going to do is you're going to pull down that database of 10,000 people. You get those into records. Those records are going to look kind of like this, or actually probably more like this because you'd have their ID as well. But then what you're going to do is find any cases where, using AI or whatever, actually machine learning, not artificial intelligence, but machine learning, you're going to find any cases where they posted harassing information on their Facebook profile, or Twitter, Instagram, and all the rest. You're going to do a search. So you're going to do this in parallel because you have 10,000 people to look through. And you don't want to change their information in their record about who they are, their ID, their first name and last name. But maybe what you do is you create a public class that is they call discovery model, where you say prop user1 is the user lookup user, where that is user1 is a record, but it's a property inside a class. That's fine. And then you can have incidents found like this, and maybe a list of string incidents. I don't know, something like that. By the way, control dot to add the using statement there I need for my collections. But so this class would have your read-only information about the user, and then you would populate the values of the things that you found based upon the search. So you'd get this whole list of records from the database, and then you'd create this class that says, okay, this is the user I'm talking about, and here are the associated data points that I found online. So that might be another case where you'd use records. Basically, anytime you want to work or can work with read-only data. Anytime you can work with read-only data, a record might be the solution. You just have to commit to the fact that this data is read-only. So those are the times to use records. Let's talk about when not to use records. Well, the first time is when you need to change the data. For example, entity framework. This is one of the questions I heard asked almost immediately when I was listening to a demonstration about records. The question was asked, well, will this work with an entity framework? And the answer is, well, no, not yet. And they're thinking about C#10 and maybe they've got to figure something out for this. But think about that, though. In entity framework especially, we have the idea of change tracking, where you make a change to a value and it goes, oh, I'm dirty. I need to update this value in the database. Well, you can't do that in a record because it will never be dirty because it's never going to change. Dirty means a value has been changed. So that's not a good case for this. If you need to do any kind of tracking, it won't work. And entity framework is really big on that. So it just won't work to try and shoehorn records into entity framework. I haven't tried it yet, but it seems as though it should work just fine in Dapper. Because typically in Dapper, we don't have the idea of change tracking unless we implement it. But we could say, you know what? This is read-only data. No problem. I'm just going to use records instead. And since they're essentially objects with extra stuff, classes with extra stuff, it should be fine. I'm going to test it out and we'll try it out probably in the future. But if you have any kind of mutation of your object or any part of your object, then records is not for you. And I think that's probably about it for when not to use it. But in general, we change objects all the time. So if you have to default, if you don't know, use a class. If you are absolutely certain and you know that it's not something like this where you need to have change, but you're absolutely certain it's going to be read-only data, then go ahead and use records. Try them out. But I would encourage you to lean towards using classes, not records, unless you're absolutely sure. That's the default. Default is class. Because C# is object-oriented. A class is an object that is mutable. That's what they're designed to do, and that's what C# is designed to work with. So therefore, I would encourage that unless you know for certain that you don't need to have that mutability. You can be immutable, in which case a record might be the way to go. Now, one final thing I want to go over in here, I debated even putting this in, but I've decided that it's important enough that I want to show you, but I'm going to put in big, bold letters, do not do any of the below. Okay, is that clear enough? Do I need to put the little flower box around it? I'll put the flower box around it because I'm going to be very clear. Jump up and down. Don't do this. I want to show you what not to do because you may say, oh, well, I saw someone do this and it works. Just don't do it. Public, record. What are we on now? Record 2 or 3? I think we're on record. Yep, record 2 already. So this is record 3. Record 3. Open, close, curly brace. I've already broken the syntax of the constructor parameter. What's wrong here? Why am I yelling at you saying do not do this? That right there. Set. Guess what? This works. It shouldn't in some ways. I think that this is very problematic for a number of reasons. One, you don't have that nice constructor, so you have no destructor. And another, you have mutability. You have the ability to change these values. This will work, but don't do it. It defeats the purpose of a record and it makes your code smell. It can cause instability because if you're expecting that hash code to not change, you're going to have a problem. So two different values aren't going to line up right. It's going to cause messes in your code, and your fellow developers are going to expect a record to be immutable. This is not immutable. This is mutable. Meaning it can change. That's going to cause expectation problems that will cause assumptions about this record that aren't true. So just to be clear here, the set makes this record mutable. Bad. Okay, just to be clear here. So that's one thing that I think you should avoid. I know you should avoid when dealing with records. With that being said, yes, you can. Just because you can do something does not mean you should do something. But there's probably some weird edge case where you're like, yeah, but Tim, I know in this one squirrely example that there's, if you stand 1 foot and hop around in a circle blindfolded, that it's more important to have a mutable object in a record. Okay. Yeah, I get it. That's not the majority of life. The majority of life is don't do this. Also, no constructor, so no deconstructor. So that's another problem with this setup. Another thing that you shouldn't do, and there's not really a code sample for this, but don't just make clones all over to update state. So we have this ability, and let's get the illustration here up on the screen. So it's, of course, inside the section I collapsed. But we have this right here, where what we're doing is we're basically making a clone of this and just mutating one value or changing one value. So this is now a copy of this, but this has a different first name. You could, in theory, say, well, every time I'm going to make a change to a record, I'll just create a new object and mutate it over or copy it over and use the with statement to change the value we need to. That's making a copy of that object. It's duplicating in memory the entire class. That's not, now to be clear, it's a shallow copy, meaning if you have a class instance as one of your objects or one of your properties, it's not going to make a copy of all the values of that class, just the reference. But even so, it's making a copy of all those values in memory. So you're being not very efficient here. And that's where a class is superior in the fact that you don't have to make a copy of every property. You're just overwriting the one property with a new value. So this syntax is fine. It's great for either making a copy in order to change one value or to change a couple of values to make a new object or a new type, but it's not for really taking the place of mutability. If you need mutability, use a class. Don't try and force records to be mutable. So just want to point that out as well. So that's records. And I would say in a nutshell, but that's definitely not a nutshell. It's taking us 70 minutes to get to this point. There's a lot of stuff going on with records. They are in a lot of ways really cool. And I wish in some ways we take some of what we have and put them back into classes. You know, that ToString is really nice. We can't override the hash code, but we could do some other things, or make an extension off of class or something like that that does most of this stuff, because a lot of this stuff is great stuff even for objects that are mutable. But unfortunately, we only get it for records, and records are supposed to be immutable. So that's what records are. That's how they work. That's how to work with them, how to use them, how to tweak them and modify them. And really kind of, this was a deep dive, not just an intro, but a deep dive into records to make sure that you have a good solid foundation and how to use them effectively, and also know when to use and when not to. That's kind of the real world side of this thing, where it's not just a nice shiny new object, it's actually something that you're going to use. So now you're prepared to know when and how to use records. If you have any questions, leave them down in the comments. If you have any thoughts, leave them down in the comments. If you saw I missed something, let me know. One other thing I want to point out is, and let's just real quick, I'm going to do this. I'm going to create a real quick demo, very, very quick. It's going to take 2 minutes. It's going to be a console app, and top level call. This is something I missed that viewers pointed out. I appreciate the shout out, and I appreciate you pointing this out. So this is a top level call. Let's bring this back to the beginning, and let's change our, if we look at the project file, notice netcore app 3.1. It's, is it just net 5.0? Yep. So if you just change this to net 5.0, I showed you how to change it. Go to right click and go to properties, but this is the same thing. And now that's a top level call. We saw that, and I showed that off in the previous video where we talked about the new stuff in C#9 that was not records. But one of the things I said in there was that you don't have access to args here. And that was one of the things, if we looked back at this, we have this string args, which are command line arguments that are passed into our application. And some viewers of mine said, "You're wrong, Tim." Very nicely, they said that, but they're wrong. I'm wrong. There is a way to access that. And so if I were to say CW, I can say args. Notice that? I still have access to that. Even though it doesn't specify it anywhere, those are still available to me. So I just want to point that out, that, that some of the viewer pointed out. And, I'm going to definitely try. I can't modify an existing video, but I can definitely show you in the next video or the next time we have a chance to look at something like that. So if you see something with these records, of course, I'm very new to records, just like everybody else is because they're pretty new. But if you saw something, you're like, "Hey, Tim, you missed something," let me know. I will try and come back and circle around to it again, and and show it off at that point. Okay. So I thank you very much. I appreciate you watching till the end. It's been a long one, but hopefully it's been a lot of value to you. Don't forget, get the source code down in the description. There's a link to get that, as well as that link to my mailing list. Like I said, next week, for not very long, we'll have the Black Friday sale. That Black Friday sale is going to be 30, 40, 50% off a lot of my courses. And when I say that, I don't mean that most of them will be 30% off. Actually, most of my courses will be more like 40 or 50% off. A few will be a 30% off. It's not going to be every course. And we'll talk about that more later, but the Foundation C# series is actually really underpriced. I really try to keep it as low as possible. So that's kind of an everyday low price. We don't discount that. But everything else pretty much will be discounted. So just that's coming up. Make sure you're on the mailing list so you hear all about it and get those values. Okay? Thanks for watching. And as always, I am Tim Corey.